Section 10.2, Simplifying Radical Expressions. Our essential question is, how do you simplify radicals? A radical expression is an expression with the square root in it. Another name for square root is radical. Simplest radical form, what that means is kind of like when you reduce a fraction. Reducing a fraction means that there are no common factors between the numerator and denominator anymore, so it's in simplest form. Simplest radical form means that there are no perfect square factors in the radical. So no perfect square factors are left in the radical. That'll make more sense in the next slide.
Josiah Cooper, if you're in the building, please report to the office. Josiah Cooper, if you're in the building, please report to the office.
Okay, so let's try this out. Notice across the top of the screen, I have written the first 12 perfect square numbers, perfect squares. Remember, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. So these are my perfect squares. So to simplify the square root of 32, what I need you to think about is what numbers are factors of 32? Now, factors of 32 could be 1 and 32, 2 and 16, or 4 and 8. The only, well, not the only one, I take that back. The largest perfect square factor, so up on our list here, the largest perfect square factor of 32 is 16. So I'm going to factor the 32 into 16 times 2. The square root of 16 is 4. So I can change the square root of 16 into 4, and simplest radical form, the square root of 32 equals 4 times the square root of 2. So again, I look for factors of 32, and then I specifically want to find the largest perfect square factor of 32. That's the one that I want to use to break it down to simplest radical form. So 32 is the same as 16 times 2. So I can separate the square roots. So the square root of 16 times the square root of 2 is the same as the square root of 32. Then the one that's a perfect square, the 16, I take the square root of that. That square root equals 4. So there's not a square root over it anymore. It's not a radical anymore. So my final answer is 4 times the square root of 2. The next one, I have the square root of 75. So to factor this one, I look at the list across the top, and for this one, I am going to use 25. 25 is the largest perfect square factor of 75. 75 is 25 times 3, so the square root of 75 is the square root of 25 times the square root of 3. 25 is the perfect square. The square root of 25 is 5, so my final answer is 5 times the square root of 3. In geometry class, you're going to need to be able to write your answers in simplest radical form. And in particular, when you're working with the distance formula or the Pythagorean theorem, or even with some geometric formulas for areas, surface areas, volumes, things like that, your answers often will have to be written in simplest radical form. Square root of 200 is our third example. The square root of 200 can be broken down. If I look at my list, I can go all the way to the 100 on this one. 200 is 100 times 2. So square root of 100 times the square root of 2. The square root of 100 is 10. So simplest radical form is 10 times the square root of 2. Okay, 3 more basic examples before we switch it up a little bit. The square root of 80. Sometimes you may need to use a calculator on these. If you're not very familiar with larger factors for numbers, 80 happens to be 16 times 5. So the square root of 16 is 4, so 4 times the square root of 5. Let's say that you were solving this and you got to the 4 and you knew that the square root of 80 could be written as the square root of 4 times the square root of 20. 4 times 20 is 80. The problem with this, though, is that 20 can be broken down again. So you would really need to take that 20 and make that one the square root of 4 times the square root of 5, like this. Then the square root of 4 is 2, another square root of 4 is another 2, and then you have the square root of 5, so 2 times 2 is 4 times the square root of 5. So you can get to the same answer if you use a smaller perfect square factor, it's just that it's going to take you longer. So it's always best if you can find the largest perfect square factor for your radical right from the beginning. Okay, 54. 54 is 9 times 6, so the square root of 9 is 3. 3 times the square root of 6 for that one. And the square root of 120. 120 would be 4. 4 times 30. And 30, if I check all of these numbers that are less than 30, are any of those factors of 30? No. So square root of 4 is 2, so 2 times the square root of 30 is our simplest radical form. What simplest radical form does for you in geometry is it keeps your answer exact, because you're not using the calculator, you're not rounding anything off, you're not approximating anything. This is still an exact answer, so it's more precise. Now our last slide, you notice that there's a number in front of each of these radicals. That number is being multiplied times the square root. So the first one is 3 times the square root of 108. I'm going to leave that 3 alone and simplify the square root of 108. 108, let's see, what can we divide that by? 36. 36 times 3. And then the square root of 36 is 6. So the 3 that was in front of my radical at the beginning has to get multiplied now by the 6 that I got from the square root of 36. So my final answer is 18 times the square root of 3. Next one, 2 times the square root of 244. The square root of 244 is, let's see, what factors into 244? Four. So we can use 4 times 61. The square root of 4 is 2. So 2 times 2 is 4. 4 times the square root of 61. And the last one, 5 times the square root of 162. 162 would be 81 times 2. So the square root of 81 is 9. 5 times 9 is 45. So 45 times the square root of 2. So that is simplifying radicals and keeping your answer in simplest radical form. You should be able to write a summary now and check with your teacher to figure out what your assignment is.